Let's talk about the domain and range of a function. So let's talk about domain and range. Domain and range of a function. So domain is basically in most cases, domain is my input value, and range is my output value. So let's consider a function. So my function is y is equal to fx, and that is equal to x plus 3. Now domain is all the values of x that we can plug in here inside the function, and we get the unique values of y for those given values of x. So what I'm going to do, I'm going to consider some random values of x. So if I consider x is equal to, suppose, like -10, what will be the value of y? Then y will be y equals to f of -10. So let's substitute the value of x as -10. So I have -10 plus 3, which is what? -10 plus 3 is -7. Now, if I substitute x is equal to, suppose, like 7, what will be the value of y? Y will be f of 7, which is basically what? For each x, I'm going to substitute by 7. So I have 7 plus 3. That gives me what? 10. Now, let's try to graph this function. So, if I graph this function, this is my x-axis, x dash, and this is my y-axis, y and y dash. Now, the graph of this function is basically y-intercept is 3, so I have 1, 2, 3. This is my y-intercept, and my slope is 1 over 1. As you can see, we already know how to graph it. So the graph of this function is something like this. As you can see, on this end I have a negative infinity, and on this end I have a positive infinity. So basically, we can consider any value from negative infinity to positive infinity. So, what is the domain of this function? Domain of this function is all possible value. I should write all possible x values. All possible x values. All possible x values. So my domain is basically a number line R. Now, what is my range? What is my range? For the range for this function is, over here, as you can see, this goes to negative infinity and this goes to positive infinity. So, for range for this particular function is all possible y values. All possible y values. So the range for this function would be, range is R, like a number line. So the domain and range for this function is a number line. Now let's consider another example. So my second example is, this was basically my first example. My second example is, I'm going to consider a function. My function is f of x is equal to the square root of 16 minus x squared. Now, you need to understand that we can only substitute the value of x that gives me the positive value of the output. Because if the overall value inside is negative, inside the square root is negative, then I cannot find any real value for the square root of a negative number. So that is not possible, right? So one thing that I can do, I can substitute all the values of x that is equal to 0, because if I put something over here, the lowest value that I can find as square root is 0. Anything lower than that is a negative number and I cannot find the square root for that value. So the domain would be, like the x values that I can substitute would be 16 minus x squared, that is 0. If I simplify, I will add x squared on both sides, right? And if I simplify further, this is out and I have 16 is equal to x squared. I want to find the value of x, so I can take the square root on both sides and I can get x is equal to plus minus 4. So the value of x lies between negative 4 to 4. Now, let's try to see what happens if I substitute something that is not lying between negative 4 and 4. So before we go any further, I'm going to draw my x-axis. This is my x-axis and this is my y-axis. Y dash. Now my values are from negative 4 right here to 4, right? And if I grab this function, then it will be something like this, right? A semicircle, right? Something like that. Now, if I substitute anything that doesn't lie between negative 4 and 4, like for an example, if I substitute 5, if I substitute x is equal to 5, what will happen? My f of 5 will be square root of 16 minus 5 squared. Alright, now let's simplify further, and if we do that, we have 16 minus 5 squared is 25, and 16 minus 25 is square root of negative number. Can you see? I cannot find a square root of negative 9 that gives me a positive value of function. So the value is not real, right? So if I consider any value that doesn't lie in between these two values, then I'm not going to get the real value for the function, right? So my domain for this function is, f(x) is what? My domain is close interval negative 4 to 4. So domain for this function is from negative 4 to 4. Now let's talk about the range. So the range of this function is, range of fx is basically what? All the values that I can find as square root, and the lowest value that I can find as square root is what? The square root of 0, that gives me 0, right? So my lowest value will be 0, and I can go all the way to positive infinity, because I am good to find the square root of any value that is equal to 0 or more than 0 and all the way to positive infinity. But I would not be able to find the square root of any value that is less than 0. So the range of this function is starting at 0 and goes all the way to positive infinity. And this is how we will find the domain and range of any given function.